We are on non-perfect squares. 3.2, we listed our perfect squares yesterday up to 12 times 12 for 144. And now I told you we were going to work on non-perfect squares today, which you already saw how easy it was. So the first thing it says in the directions is find the perfect square before and after the irrational number. So I'm looking for the perfect square before 62 and after 62. Go ahead and do that. Write it down. What is the perfect square before and after 62? 3, what's the perfect square before 62? Correct. So 62 is in between 49 and 64. So we have the square root of 49 before it and then the square root of 64 after it. Step 2 says make a number line. So I'm just going to go like this. Make a number line. What's the square root of 49? 7. What's the square root of 64? Again, I've narrowed it down in between two whole numbers, 7 and 8. Now I just need to figure out where between those two. So the next step says find the halfway point. So I'm going to put 7.5 is halfway between 7 and 8. And then I need to see, is the square root of 62 closer to the square root of 49, closer to the halfway point, or closer to the square root of 64? How far is 49 and 62? 49 to 50. 50 to 62 is 12 plus 1 is, that's 13 units away. How far away is 62 and 64? It's only 2 units away from it. So are we closer to 7, 7.5, or 8? We are definitely right here over near 8. Remember, if these distance numbers are closer to each other, that's when you know you'll be closer to 7.5. All right, so we're going to say that the square root of 62 is approximately what? 7.5 is right here. Jackson, what do you got? 7.9? I probably would not put that one only because I know 63 could be there too. You got 62, 63, and 64. I would probably just back it off one more. Even if you did put 7.9, I think it's closer to 7.8, and I did say you could be one off. So you could have 7.9 or 7.7 and still not get it wrong. But think about, I'm not sure if you were here when I did that, the square roots all go right in a row. It would be the square root of 62, 63, 64, which is a perfect square, 65. So they all go right in order for square roots. All right, let's look at the number line, and we're going to order some numbers. And I would try to pick out the easiest ones first. Which one do you want to do first? 2.5, that's the one I would go for. -2.5, -1, -2, and you put it on top, -2.5. The number line is on bottom, and whatever I am trying to show where it belongs, we put on top. What's the next one you want to do? 4/3, very good. I would pick that one too. Although I don't like 4/3 very much, Mia. Is there another way I can think about 4/3 so I can figure out where it might be on my number line? Exactly, it's an improper fraction. And so I know 3 goes into 4 once, and there's 1 piece left over. 1 1/3. That helps me to really see between which two whole numbers. So we're between 1 and 2. And I know that it's broken into thirds. That means there's 3 pieces in there. So if I just make the best I can, like that, break it into 3 even pieces, then I can see 1 1/3, 1 2/3, and 1 3/3 brings us to 2. So here's 1 1/3. And again, we're using those original numbers, 4/3. Always. I only manipulate them so I can better understand them. But I would use the original 4/3. All right, that one's done. Anybody else got one that they're like, hey, this is pretty good? Square root of 9, what does it equal? It's 3. So right here, I'm going to put the square root of 9. Now we need to estimate the square root of 13. What's our perfect square before and after 13 so I can look on my number line? Very good. The square root of 9 and the square root of 16 would be before and after it. So we know the square root of 9 is right here. The square root of 16 would be 4, so I'm going to put that here. And then again, I want to think about those distances between them. What's the distance between 9 and 13? It's 4 units away. How about 13 and 16? So where are we this time? We're closer to the middle. So I'm going to actually just put 3.5 on my number line, and then I'm going to think about it for a second. Am I going to be on the left-hand side of 3.5 or on the right? Because it's not going to be right on it, because those numbers would have to be exactly the same. Am I going to be on the left of 3.5 or on the right of it? There's less distance here on the right. That means it's a little bit closer on this side. So I'm going to go here, and I'm going to put the square root of 13. And then we have the negative square root of 5. I'm going to be over here then. Negative side. So what is a perfect square near the square root of 5? The negative square root of 4, which would be 2, negative 2. So I'm not even going to look for the other one, because the negative square root of 4 is right near 5. The question is the negative square root of 5 before it or after it? It's after it. So I'm going to just draw a little arrow right here and put the negative square root of 5. Okay, one more thing and then we're done, and you have those 2 questions to do. And you may want to go back and look at your homework and make sure you're using original numbers. All right, right here. So the square root of 4 is really a 2 by 2, which is just 4 squares. There is the square root of 4, which equals what? The square root of 4 equals, thank you, Jackson, 2. $16, I'm just going to use the top corner and come down for a 4 by 4. This would be a 4 by 4. And we know the square of 16 is 4. Not a perfect square. What's the perfect square before 7 and after 7? 4 and 9. So I'm going to start with the 4. It's between those 2 numbers. So it also includes 9. So I'm going to build on the 4 and make it a 3 by 3. The square root of 7 is bigger than the square root of 4, so I know it includes all of 4. It's going to be all of that. It's not a perfect square, but it does still get a little bigger than that. That's why it's not a perfect square. If it had more or less, it would be. You will not have any questions on a cube root. This is algebra 2, but the roots do go higher. Remember, this has a 2 here. We don't write it. It's understood to be there. A square root does have a 2. If they want anything higher, they have to put the number in there. This means I'm looking for something times itself 3 times. That equals 64. We've got 2-dimensional figures, and now we've got a cube root that becomes 3-dimensional. And I know that 4 times 4 times 4 is 64. So the cube root of 64 is just 4. And you don't have to do this part, but what would it look like on my cube then? I would have to have 4 on all sides. Here's my fronts. And then I have my top. And I have this side in the middle and the 2 other ones. And you don't have to do that, but that's what it would look like. I love art. You love it so much. And science, it all explains the world out there. And what do we use to do that? We use math to explain it.